is talk a little bit specifically about detection and containment, realizing, of course, that when you deal with any particular security problem, there's a number of different types of defenses that you want to deploy to have defense in depth. You want to be able to assess issues, you want to be able to prevent issues wherever you can, you want to detect, you want to contain, and you want to assure users and customers. But I'm going to focus specifically on detection and containment, and I'll talk about how mod anti-malware can provide the containment to today's world, which doesn't exist today. Make sense? Any quick questions? No? Good. Okay. So this is a hard problem. We need to bring the entire life cycle of protection to the web, and there's a number of kind of sub-problems that we need to address. One of the key problems that we need to address is that whenever a website gets infected, it's important to root cause exactly where the infection is coming from, because it could be due to a whole bunch of different things on that website. And you want to be able to root cause what happened in a targeted way. And if you think about this, this is a little bit different than, say, what a search engine or a browser or an AV provider needs to do, a traditional AV provider, that is. In those cases, they simply need to detect that the web page is infected and put up the appropriate messages. On the other hand, if we want to be able to contain the impact and we want to allow users to be able to continue to use the site, we need to figure out what is the root cause of the problem, what is the widget that's causing the problem, what is the ad that's causing the problem, etc., and identify that and basically strip that out, or basically make the website still usable, continue to serve it, but strip that out. So we need to root cause the problem. And so, doing things like, on a web server. So basically, what mod anti-malware does from the abstract for this talk is it's a web server module that's written for both Apache as well as IIS, that once installed on a web server, what it'll do is that if and when a website gets infected and a monitoring service of some kind detects it and sends over appropriate quarantining information to this web server module, that web server module will allow pages to continue to be served, but it'll strip it out in real time. It'll strip out the malicious code in real time. And in order to do that, it needs to be able to parse the page in real time really fast, in a really high performance way, and basically continue to serve the pages. Note that one interesting thing about this approach, where you have the web server and a web server module doing this containment, is that it doesn't matter if there was some file on the web server that was infected, or there was some malicious code inserted into some part of the database that may be part of a, say, content management system. Wherever the infection is coming from, it's going to get stripped out before it gets served to the user. So it's a hard problem, and mod anti-malware is some pretty cool technology to address the problem. So to just talk a little bit more about this root cause issue. For those of you that are familiar with web-based malware, you know that there might be various cases where bad guys will inject JavaScript into a website. So they might inject this script source tag, which refers to some a.js file at external.com, typically some attacker domain. And when that JavaScript runs, it does a lot of interesting things. One of the things that it will do is it will fingerprint what browser the user is using, it'll fingerprint what version of the operating system the user is using, it'll fingerprint what are all the third-party browser plugins that are being used. And it will then leverage a database of exploits that the attackers have, and will choose the optimal exploit to serve, to basically take control of the user's machine. And while doing this fingerprinting process, it may generate additional code, it may generate additional scripts or iframes on the page. And so one of the key things here is that when this code unravels, there's a lot of intermediate code that gets generated. But if we're going to do a successful job of containing the problem, it's important to be able to trace back the lineage of all this code that eventually resulted in a drive-by download, and trace it back to the element in the top level page that caused the problem. So when you do, so basically in order to contain the problem, you need to have really good detection. You really need to have good detection that root causes what is the top level page element. So the detection technology needs to not only figure out what's the top level page, but the ideal detection should be behavioral. There's many detection algorithms that rely on signatures, but one of the downsides of signatures is that it may not be most effective in catching zero-day malware. And from what we've seen occurring in the world of web-based malware, most of the attacks are in fact 0 days. So there are 0 days which refer to new domains, which rely on all kinds of new techniques for exploiting. And so the detection should typically be behavioral. It should need to be able to compute the lineage back to the top level code snippet which resulted in the problem. And an ideal detection technology can leverage machine learning like techniques which for any web page that's analyzed generate tons of features of that web page and or signals that may indicate not only that there's some probability that the web page is infected, but that there's a overwhelmingly high probability that the web page is infected. And so there's some certain requirements for a detection service to be in place in order to do very solid containment. So anyhow, I talked a little bit about detection, but I'm going to spend most of the rest of the talk talking about the containment piece and talking about mod anti-malware. So what is the high-level architecture for mod anti-malware? The high-level architecture is one in which there is a client or a potential victim website that's running a web server on which we've installed mod anti-malware. And that's one side of the house. The other side of the house is the detection side of the house, where a good detection service should be able to crawl all the URLs on the web server, submit it to a set of content and malware analyzers, and basically generate a report for the webmaster, but also more importantly with regards to quarantining, send over automated quarantining directives to mod anti-malware to contain the infection. Now, one thing I should mention about this architecture is that mod anti-malware is analogous to other web server modules for Apache, for instance, where if you install mod SSL, it will it'll basically hook in as a output filter, for instance. And one thing I should mention is that where it's different though is that it's a remotely managed web server module. So there's a set of problems that need to be solved with regards to making sure that the monitoring service can securely authenticate, can send over appropriate configuration directives, can do things like make sure to have those configuration directives go into effect without needing to restart the web server, because typically whenever you change a web server configuration you need to restart the thing. But if you want to provide solid containment, all these problems need to be solved such that the web server can just continue to function and incorporate the directives without having to restart. And so I'll talk about the technical details of how we get that to happen. Let's see. I think what I'll do at this point is, now that I've shown you the architecture, just show you mod anti-malware in action and do that before I delve into the technical details. So because the wireless isn't working so well in this room, I'm going to show the demo using a video that I have here. And basically this video shows an example of Mr. Rogers' website getting infected and shows how mod anti-malware quarantines Mr. Rogers' website. And so the reason we chose Mr. Rogers' website is because this is motivated based on a true story. Mr. Rogers' website got infected in the early part of 2009. One of my co-founders actually reached out to their hosting provider and helped clean up Mr. Rogers' website. So it's it's an example that we chose and mocked up because it's based on a true story. And then the other thing that it illustrates is that the attackers just have no shame, right? The cyber criminals have no shame. They'll attack whomever, whatever. I used to love Mr. Rogers as a kid. I don't know if any of you folks did as well, but it's just kind of unfortunate that the bad guys are infecting children accessing websites. The movie doesn't have audio, so we should be in good shape. I'll supplement the audio. Great. Okay, our tech staff got a little worried. In any case, so we have Mr. Rogers' website, and in this version of Mr. Rogers' website, it's been infected, and that infection has been depicted using the skeletons on the page. Of course, in a real attack, this would be an invisible iframe instead of being a visible iframe. And the other thing that I should mention about it is that in a real attack, of course, it'll serve the drive-by download. So this website, Mr. Rogers' website, is being monitored by Daswani in this case, and Mr. Rogers' website also has the mod anti-malware web server extension deployed on it. So when the website is when the infection on the website is detected, the user, either the security team or the webmaster, will receive a email alert that looks like this, which says that there has been an infection detected and that the site may very well be infected, and you can click here to view a report. So pretty much when the webmaster or the security team clicks here to view the full report, it'll take the user to a page on Daswani.com in this case, because we're running the monitoring service. And what it'll do is it'll identify that the website is at risk for being blacklisted by Google, by McAfee Site Advisor, by Norton SafeWeb, because there's an infection on it. And in addition to the site being at risk for being blacklisted, one of the things that we identify is that the infection is on this particular page. It's on the URL /test, and the infection is due to a malicious iframe that has been injected into the page. Now, because the web server extension, because the mod anti-malware web server extension has been deployed, the security team or the webmaster also sees this in the report, a checkbox that says quarantine these infected URLs to protect my users. And once that gets checked and the security team or webmaster clicks update, what happens is that the backend monitoring service, in this case at Daswani.com, will send automated quarantining instructions to the mod anti-malware module running on the web server. So a dialog box comes up saying that the quarantining has been enabled, and if we now go back to Mr. Rogers' website and simulate another user coming to the website, what we'll see is that once the quarantining directives go into effect, the page continues to get served, but the malware got automatically stripped out. So that's how mod anti-malware works in a nutshell. It basically provided, in this case Mr. Rogers' website, business continuity even in the case of an infection. If a search engine crawler was to visit Mr. Rogers' website, then even though it is infected, it will not blacklist the site because the malware is not being served because mod anti-malware is containing it. Make sense? Any questions I can take about that? No? Oh, question, go ahead. Oh, okay. So the question is, how does mod anti-malware distinguish something that's malicious versus, say, something that's just showing an image? And the answer to that is that mod anti-malware, because of the fact that it needs to perform in a very high efficient fashion, it doesn't make that distinction. Basically, the monitoring service on the back end made that distinction and send over an automated quarantining directive to mod anti-malware which said that, hey, this thing is bad, this iframe is bad, strip it out of the page, but continue to serve it in a high performance fashion. If mod anti-malware was written in a way where it had attempted to make that distinction, it would probably draw the performance of the web server down to down to a crawl, which would not be acceptable. Great. So let me jump back to the presentation. Let's see.